All right, we're getting into signed numbers. Pull out my pen here. There's our objectives for this section. Let's just talk about the real numbers real quick. So, just a little bit of vocabulary. The natural numbers, so that's denoted by this syllabus right there. The natural numbers are your counting numbers 1, 2, 3, 4, 5, 6. The whole numbers, denoted just with a capital W, is the set from 0, and then it includes all the natural numbers. That's the whole numbers, right? Whole numbers include 0. The integers, there's your integers, and that's denoted with that kind of funny looking Z right there. That includes the negatives, right? That includes the negatives. And finally, the rational numbers are also real numbers, and all those, the naturals, the wholes, and the integers are also rational numbers. Rational numbers can be written in this form, A over B, where A and B are integers, right? So for example, 2 over 3 is a rational number, or even just 7 over 1. Of course, 7 over 1 is just 7. But anything that can be written in the form A over B, where A and B are integers. Another one would be like -1/3, right? So any integer over another integer. So it can be written in fraction form. Here's another one, 0.1 repeated, right? 0.1 repeated is in fraction form 1/9, right? So in decimal form, it'll either repeat, the decimal will repeat, or it will terminate, right? For example, like 0.2, it stops, right? That's 2/10 or 1/5, right? Now, the irrational numbers in decimal form will not terminate or repeat. For example, pi, 3.14159, blah, blah, blah. There's no pattern to it, just keeps going in decimal form. Square root of 2, decimal form also doesn't terminate or repeat. 1.414213562, blah, blah, blah. Right, so irrational numbers in decimal form do not terminate or repeat. Those are some classic irrational numbers. Square root of 7 is another one. Square root of 9 is not, because square root of 9 is 3, right? So that's actually a natural number. Okay. Any questions on a little bit of vocabulary, natural, whole number? And I should say the set of all rational numbers and irrational numbers. Rational numbers are used with a kind of a funny looking Q like that, irrational with a capital I. These make up what's called, all of these numbers are what's called real numbers. Set of all real numbers. So these two, all these sets of numbers are referred to as all types of real numbers. All right, let's use some integers to describe each of the following situations. So 13 degrees above 0. So that's a positive 13 degrees, right? A loss would be negative, right? -$21. 350 feet below, what do you guys think this is going to be? You can go ahead and punch it into the chat there. 350 feet below 0 would be represented by below sea level. Good, a -350, exactly. Good, you guys, very nice. Say Jasmine, yep, good, Allison, awesome. A gain would be, a gain of 27 yards would be positive, exactly, positive 27, yep. Awesome, thanks you guys, Peyton, Allison, nice. All right, let's talk about the number line, right? So the number line, like -3.5 would be right there between, right there between -3 and 4, right? -7/6. Well, -7/6 is -1 1/6, right? So -1 and down a little bit, right? Square root of 3 is 1.73, right? So this one right here, 1.73 is 1 and 0.73 up to the way up to 2 and so on. Pi is 3.14. So let's go ahead and graph this on a number line, negative 4.7. So negative 4.7 would be between what and what? And it's a little closer to who on the number line? Good, Valerie, yep, and Jose, excellent, yep, a little closer to 5. Yep, there's, so negative 4.7 is about right there. Let's go ahead and order these. You know, the nice thing about a number line, there's negative 9, and negative 8.3, there's negative 9, negative 8.3 is right there, and then 9 is right there, right? If you put them on a number line, that'll order it from smallest to largest for you. So there's the smallest, there's the next smallest, and so on. There's smallest to largest. All right, let's talk about inequality symbols. So there's our less than, and if we put a line under it, less than or equal to, right? For example, 8 is less than 9, right? 8 is also less than or equal to 9. That's also true. This is true. That's true. And 9 is less than or equal to 9. That's also true, right? 9 is less than or equal to. Is 9 strictly less than 9? No, that's false, right? Then we got our greater than. We got our greater than or equal to sign. And finally, we have not equal to, right? Not equal to. All right, so what would make this true? You guys can go ahead and just type it in the chat. Negative 21 is what to 12? Of course, that would be less than. Good, Valerie. That's awesome. Yep. Negative 21 is less than 12. That's right. All right, let's talk about absolute value. So absolute value is your distance from 0. For example, the absolute value of negative 3, here's negative 3. I say, well, that's a distance of 3. That's one of our definitions of the absolute value. We'll get into the algebraic definition as well, but we're going to talk about absolute value being a distance from 0 today. All right. All right. Any questions from you guys? Let me stop this.